Hi everybody! In this video we are going to talk about multiplying and dividing radicals. In the previous video we went into how to simplify radicals. Now we're moving forward and multiplying and dividing them. So our first example, we're going to multiply and then simplify. Notice we have two factors, both of which contain radicals, specifically square roots. Now we have options with multiplication where we can rearrange terms. So we're going to take the numbers not in the square roots and multiply those. And then the two numbers in the square roots, we talked about this in the last video, you can actually combine those because you are multiplying. So a square root times another square root can be combined as one giant square root where you're multiplying the radicand. And so on the outside we have a 12. Now on the inside, I could just multiply what 6 times 15 is, but because I want to simplify, and you always want to simplify radicals, you actually break this down instead. And here's why. If we break it down before we make it larger, because 6 times 15 would become bigger, a bigger number to work with, we break it down because we know quickly that 6 is 2 times 3, and 15 is 3 times 5. And now because you are working with a square root, you are looking for pairs of things, 2 of something, because that would be something squared. So in this case, 3 times 3 is 3 squared. And so we can actually take the square root of 3 squared. If it helps you, you can say 3 square root of 9, if you want to call this 9, and the 3 comes out when you take the square root. Or again, anytime you have a pair of factors, when you're working with a square root, they come out as one factor. Okay, there's 1, 2, and 1, 5 left over. That's going to stay inside the radical. And then the number that came out of the radical from taking the square root of 3 squared multiplies with the number that was already out there. So then we get 36 on the outside times square root 10 on the inside. So when multiplying radicals, you multiply the coefficients, which were the numbers outside, and then the radicands, and you do this separately. So in general, if you have one factor with an nth root, so notice we have two factors, they both have the same index for the radical. So one factor with an nth root times another factor with an nth root. You can combine the coefficients, which was the numbers on the outside, by multiplying. And then you can combine the two nth roots and make it one nth root, and you multiply what was inside of them. So let's try this one, where you are going to multiply a factor out front times a quantity, and notice this quantity has a minus sign in between the terms. So on this one, you have to be a little bit careful. You have something outside times this subtraction over here, this quantity that's being subtracted, but you have to distribute. Okay, so this 3, square root 3, has to make its way to both terms. And so notice what we're going to do. The numbers on the outside combine, so 3 times 4 is 12. And then the square root times the square root gets to be put together. So we have square root of 3 times 8, which is where the 24 came from. Then we distribute the 3 square root 3 to the next term that was inside this quantity. And then do the same thing. The 3 times the negative 5 on the outside is negative 15. And then square root 3 times square root 6 becomes square root 18. Now I wouldn't box this in just yet because I could possibly simplify the radicals. And we can. 24 has a perfect square in it. It has 4 in it. And then 18 has a perfect square in it. It's 9. So when you're simplifying the radicals, remember how this works. You want to look for the largest perfect square that goes into the radicand. So for example, 24, I could have said it's 8 times 3 or 12 times 2. But if I pick 4 times 6, I know that 4 is a perfect square. And so in the very next step, I can take the square root of it. So square root of 4 is 2. The 6 stays in because it's not a perfect square, so it stays inside the square root. Over here, square root of 9 is 3. And then the 2 stays in the square root as well. And then the numbers that we took the square root of, they multiply with what was already out front. So that's going to be a 24 square root 6, and then a minus 45 square root 2. And now we cannot go any further here because these are not like radicals. We talked about this in the last video. You can only subtract and add radicals that are like, meaning they're exactly the same as far as index and radicand. So yes, these are both square roots, but they are not both the same radicand. Here's another example. So this one, we got a little bit more going on. Notice what we have. We have a binomial, meaning two terms, times another binomial, two terms. And so this one requires that we FOIL this out, this product. So when you FOIL two terms times two terms, you will end up with 4 terms. And we have cubed roots everywhere. So every term actually has a cubed root in it. So we will use the idea of the distributive property, or think of it as the FOIL process if you've learned it that way. So we're going to start with the first term times the first term. The first term has an invisible 1 in the front, and so that's times 4. And then you have a cubed root times another cubed root. Now we're going to do the first term over here times the last term here. So this is the O part of FOILing. This is the outer times the outer terms. So our cubed root times a cubed root. And then we're going to do our inner times our inner terms. And then last times last term. And now we start to simplify. Okay, so first of all, check that we have 4 products. We do, because we FOILed this out. Now we start simplifying. Coefficients times each other on each of these 4 terms. And then the radicals are all cubed roots. So we can go ahead and combine them because they all have the same index with this little 3 up here. So this is just 4 on the outside, and then x to the 4th times x to the 1 inside, giving you x to the 5th. Over here, everything's inside the cubed root, so it just becomes cubed root 6x to the 4th. Over here, notice what you're going to get. It's going to be a 36 outside, and then 4 times x inside the cubed root. And then back here, 9 on the outside, and then 4 times 6 is 24 on the inside of the cubed root. Now, this would be an answer, but it is definitely not simplified. So let's see if we can figure out what can be simplified here. We are working with cubed roots everywhere, and so anything there's 3 of, any factors that's multiplied 3 times, like for example this x to the 5th has at least 3 x's in it, can be broken down. So we're looking for perfect cubes in each radical to see if we can simplify. So we have x to the 3rd is a perfect cube, and we just factor that from x squared. If you go backwards really quick, this is in fact x to the 5th. So just to check that we're right. Over here, x to the 4th, you can take x to the 3rd and factor that out from x, and then that is a total of x to the 4th. In the next term, there's no cubes, there's no perfect cubes, there's no 3 of anything here, so we just keep this the same. And then the last term, we have to be familiar, and we talked about this in the last video, with some perfect cubes. So it would be beneficial to know that 8 is a perfect cube, so we break down 24 as 8 times 3. So that's the breakdown step. Now we start simplifying. So cubed root of x cubed, the cube root undoes the cube, the 3rd power, and so the x just comes out right here. In the next term, the same thing happens. The cubed root undoes the 3rd power right here on x, so the x comes out. This term here just stayed the same. And in the back, what is the cubed root of 8? Well, remember what that's asking you. What number multiplied by itself 3 times equals 8? That number was 2. So cubed root of 8 was 2, so that's where the 18 came from. It was 9 times cubed root of 8, which is 2. And then that's cubed root of 3 stayed in. The very last step we would try to do is try to combine any further if there was like radicals, and there's not. So none of these radicals have the same radicand at this point. Notice it's an x squared, a 6x, a 4x, and a 3. So this is as far as we can go. This is actually the most simplified version of this answer. So division now, we just talked about multiplication. Let's go to division, is the process of splitting something into equal groups. So let's start with nice numbers. 12 divided by 4 means that we're splitting 12 items into 4 equal groups. So if I had 12 of something and I wanted to split it into 4 groups, we know that that would be 3 in each group. 12 divided by square root 3 means that we split 12 items into square root 3 equal groups. Well, square root 3 is an irrational number. If you were to type this in the calculator, the decimal would not end. It would end because your calculator screen would end, but it would keep going. It's an irrational number. So it's actually impossible to divide by square root 3 equal parts. So we have another process that we do. Instead, what we do is we rationalize the denominator. And so what we do by rationalizing is we eliminate the radical from the denominator. So we don't want it down there in the denominator anymore. And here's the process for doing it. We recognize how to undo a square root in this case. So if I take one square root and I times it by its same square root, it will undo that whole radical because you have something squared. Okay, so square root of a squared, or a times a, is just a. And so that's the idea we're about to use. So simplify square root of 1/2 by rationalizing the denominator. And so this is square root 1 on top, square root 2 on bottom. Square root of 1 is just 1. And now our denominator is irrational, so we will rationalize it. And that's going to be by getting rid of the square root by doing this process by multiplying. Okay? Now remember, we can't just randomly multiply by something because we want to. We have to multiply only by the number 1 if we're going to just work on changing the way something looks. So I don't want to change what this quantity equals. I just want to change the way it looks. So this is really just the number 1 over here, square root 2 over itself. And so if I multiply by just this funny looking number 1, it's not really changing what I started with. It just looks different. And so on bottom, which we're focusing on, the denominator, we have square root 2 times square root 2. And so that's just 2, because if you want to, you can say this is square root of 2 squared, or you can say this is square root of 4. Either way, you just get a nice 2 on bottom, no more radical on bottom. And then on top, you have 1 times square root 2, which is square root 2. So this is the answer. We were told to rationalize the denominator, which we did. We got rid of the radical from the bottom, from the denominator. And so that is a rational denominator. So we are going to simplify this expression by rationalizing the denominator. So this time it's a little bit different just because we are working with a cubed root. Now, the denominator, first of all, is irrational because it is a radical down here that we cannot simplify, cubed root of 5x. So we are going to multiply by cubed root of 5x over itself. That's the number 1 again, but that's not enough. Okay, the index here tells us we need 3 of the same factor to undo or cancel the radical. So just multiplying by another cubed root of the same radicand, it's not going to undo this cubed root, this radical. So we need it to have a third one, and here's why. Cubed root of a times cubed root of a squared, essentially, that gives us a total of 3 a's in the radicand. And so inside the radicand is a quantity cubed. Okay, so we need 3 of like factors inside of a cubed root for us to be able to undo the cube root, for the cube root to go away. So we need another one. So we have 3 of something now in terms of the same part of our radicand here. And so this is still 1. Anything divided by itself is still 1. It's a funny looking number 1. And so now on top, you just multiply whatever you end up with, but on bottom, you're focusing on, is the radical really going to go away? And so here, notice what you have. You have 3 of the same factor in the denominator inside the cubed root. So yes, it is going to go away because this radicand is just 5x cubed. So 5x cubed, when you take the cube root of that, it's just 5x. And so the bottom is taken care of. We're good to go on bottom. That was exactly what the question said to do. Rationalize the denominator. And then the rest, just simplify the numerator as much as we can. And so on top, we can say inside the cube root, this is 25x squared. And then the 5 and the 10 divide to make 2. And then one of the x's on top divides with one of the x's on bottom. So this is the simplified version here. So you can imagine if this was a fourth root, we would need 4 of the same factor inside of the fourth root to get rid of it, to get rid of the radical. So simplify 12 over square root x cubed by rationalizing the denominator. So notice the index, we are back to working on a square root. So we only need 2 of the same factors in the denominator this time. Now we could just multiply by the same exact denominator over itself, but if we do that, we are going to have to simplify it later in our work. So yes, this is definitely an option. We could multiply by this, same denominator divided by itself, or we can simplify first, and it will be easier to simplify first. So we're going to break down 18 as 9 times 2 because 9 is a perfect square. And we are going to break down x cubed as x squared times x because x squared is a perfect square. Now we are looking for perfect squares so that we can take the square root of them. So square root of 9 gave us a 3, square root of x squared gave us an x, and then the 2 and the other x just stayed inside because we don't know those square roots. They're not perfect squares. Now we still have to get rid of this radical, and so now is the point where we can multiply by the number 1, and this time it's going to be square root 2x over itself. Okay, so that it just got a lot easier to simplify first and then choose to multiply by this funny looking number 1. And so square root 2x times square root 2x is just square root 2x squared, and so the square root undoes the square, and you're left with just 2x down there. And then we have just the 12 times square root 2x on top, and then 3x on bottom, and then we simplify if we can. So this kind of got moved down a little bit, but we have a total of 6x squared on bottom, and then the 6 and the 12 divide to give us a 2. Okay, so this is rationalized because there is no radical left on bottom. It was rationalized back here in this step, but we still just needed to simplify a little bit. Okay, so in this next and last example, we have to rationalize the denominator, but this one's going to be different because of how the denominator looks. We actually have 2 terms in our denominator. And this is the first time we're seeing this. So square root of x plus 9 in our denominator makes us have to approach this differently. And so we have our expression. Now notice what happens when we try to multiply by just square root x over itself. So we try the same process we did before. We're going to multiply by square root x times itself, and what you're going to see is it's not going to get rid of the radical in the denominator. So we distribute, and the square root x is still there on bottom. Yes, it actually got rid of the first radical, so square root x times itself in the first term undid the radical, but not in the second term. And so when you have 2 terms in the denominator like this, you actually have to do something different. And what we do is we multiply by the conjugate of the radical expression. So what that means is you change the sign in the middle. So if it was a plus sign between the terms, the conjugate has a minus sign. If it was a minus sign in between, the conjugate has a plus sign. So for us, we're going to put a minus sign for the conjugate. And so here's why. When you have a binomial or 2 terms like this, and then you multiply it by the conjugate of that expression, the terms in the middle go away. They actually add up to 0. So if you were to FOIL this out, the terms in the middle add up to 0. This is difference of squares. Okay, so if we do this with radicals, look what happens. The 2 terms in the middle would add up to 0 because you'd have square root a times negative square root b, and then positive square root b times square root a. That would all become 0. And so you just have square root a squared minus square root b squared, and then the radicals do in fact undo or go away at that point. So that's what we're going to do here. So back up here, instead of multiplying by just the square root x, we actually need to multiply by square root x minus 9, the conjugate of the denominator. And we do this top and bottom. This is just the number 1 again, something divided by itself. And then we FOIL this out. Okay, so you do have to actually work out the foiling here. And once you do that, on top you'll still have these 4 terms after you FOIL, but on bottom, when you FOIL, the 2 terms in the middle add up to 0, and so you end up with just square root x times itself, which is just x, and then 9 times negative 9, which is negative 81. And so this is exactly what was asked for, the rationalizing of the denominator. There is no more radical down here. Okay,